Okay, Rams, this is one of my favorite topics here, or this little part of it is anyway. Our standard here, and you did get this in 5th grade. However, some 5th grade schools did this in the spring, and maybe it was right around the time that our school shut down, so you may not have got a great understanding of this. So we want to make for sure we understand it really well now, okay? Our standard is 6.4H. It's convert units of measurement within a measurement system, including the use of proportions and unit rates. And these are so much fun. Okay, so I want to jump down here to the bottom first. Okay, let's think about, this is what we did in class yesterday. All right, so Mrs. Torres is mailing a package that weighs 12.5 pounds, 12 5/10 pounds. The post office charges by the ounce to mail a package. How much does the package weigh in ounces? So sometimes you see it like this. This is actually an old star question, y'all. So sometimes you see it like this, where the words are written right in here, like 16 ounces is a pound, so we want to know 12.5 pounds is what, right? So what would that be right here? What I, a lot of times, will show is this, we use the same ratio table. We are comparing pounds and ounces. So we know from our formula sheets, your reference material, that 1 pound is 16 ounces. So sometimes the given ratio that goes in your problem is not actually in the problem. It comes from somewhere else. And in these problems, it'll come from your formula sheets, okay? 1 pound is 16 ounces, so 12.5 pounds would be how many ounces? Well, 1 times 12.5 is 12.5. So 16 times 12.5 is what? 16 times 12.5 is 200. So that is 200 ounces. So we just set it up as an equivalent ratio here. Sorry, y'all. 200 ounces here. All right. So that's not too hard. That's kind of like what we've already done, right? But what happens when you are trying to go from one unit to another, and it's not something that has one simple step from your ratio table or from your measurement chart, okay? So we have a little silly made-up word here for you, okay? You have just discovered a new currency. Currency means money, okay? It's a form of money. You found 20 Fritas. Each Frita is equivalent to 7 Newfits. 1 Newfit is equivalent to 3 Halligs, and 4 Halligs are worth $5. How many dollars is 20 Fritas equivalent to? You're not going to find this on any math chart, okay? These are Mrs. Moreau's made-up funny money, okay? But the first thing we do is we say, how much do we have? What are we starting with? 20 Fritas. This is my starting place. So we take our starting amount and I put it over 1. So I start with 20 Fritas and I put it over 1. Take your given amount over 1. Okay? That's important that you start with it over 1. Okay? We're going to put times. Now, we're going to say, what do I know? What kind of equivalent value or equivalent ratio can I find about Fritas? Well, each Frita is worth 7 Newfits. I should have probably color-coded this. Sorry. 1 Frita is 7 Newfits. So I'm going to put right here, I will put, if I have Fritas on top right here, I'm going to put Fritas on bottom. Oh, look at that. Miss Scott to the rescue. Thank you. Okay, so I'm going to switch colors here for us. So I'm going to say each Frita here. Oh, that's light green. A little too light for me, but there we go. Each Frita is 7 Newfits. So 1 Frita is 7 Newfits. That's a funny thing there, right? So this ratio here that I'm boxing in is right here. So 1 Frita is 7 Newfits. Now, what am I going to do next? Well, let's look at my Newfits. Can I get from Newfits to something else? Yes, I can get from Newfits to Halligs. I know, these funny, funny words, right? Okay, so now we're going to put times again. And I'm going to put Newfits and Halligs here. They are equivalent, so I'm going to put them right over each other, right? It's like saying 7 over 7 is still 1. So when I write this, I have to make for sure if I have Newfits on top here, my Newfits have to go on bottom here. So 1 Newfit is equivalent to 3 Halligs. okay? 1 newfit is 3 halyx. Well, where do I go next? Okay, this one says 4 halyx are worth $5. So now when I write it, my 4 halyx goes on bottom because I have to have one on top and one on bottom, okay? 4 halyx is worth $5. All right, and my question is asking me how many dollars are these 20 Fridas worth? So this is my question. This is the big deal, okay? So we think about, I started with 20 Fridas, and it starts on top, okay? And I end up with dollars, and it's on top. And that's going to be my answer is in dollars. But the cool part of this is how these cancel, okay? So when it's like thinking about like a fraction. If you have the same thing on top and the same thing on bottom, they're going to cancel each other out because when you divide, it gets 0. Well, right here, if I have Fridas on top and Fridas on bottom, they cancel each other. Okay, that's great. But now I have newfits on top and newfits on bottom, and they're going to cancel each other. I have halyx on top and halyx on bottom, and they're going to cancel each other. So what I'm left with are dollars. That means my answer will be in dollars. But now I just multiply across here. So if I look at this whole thing, my top row has, let me get right here, 20 times 7 times 3 times 5. My bottom row has 1 times 1 times 1 times 4. So now we're going to multiply straight across here. Okay, well, 20 times 5 is 100, and 7 times 3 is 21. So when I multiply 100 times 21, I'm going to get 2,100. And then 1 times 1 times 1 times 4 is 4. So all I have to do here is 2,100 or 2,100 divided by 4. My answer is $525, because that's what's left. I know this is kind of weird, silly, made-up words, but the whole purpose of this is that a lot of times when students see a problem like this, they just start multiplying everything, but we don't even know what we're doing. So when it's multiple steps, because there's nothing that tells us that 20 Fridas was worth however many dollars, right? There's nothing that tells us Fridas to dollars. It tells me Fridas to newfits, newfits to halyx, halyx to dollars. So sometimes when you're going from ounces to cups to pints to quarts to gallons, you have to have multiple steps. And that's when this comes in really handy. This strategy is called dimensional analysis, but this works great when you have multiple steps to get from one thing to another. Okay, we're going to try one of those right here. Here's a football field from end zone to end zone. Now, yes, your playing field is 100 yards, but from the end zone to the end zone, it's 120 yards. So when you are trying to figure out how many inches, if you have, sorry y'all, all right, we start with 120 yards and put it over 1. I'm going to abbreviate yards and put it over 1. Now my formula sheet tells me that 1 yard is equivalent to 3 feet. I'm trying to get to inches here, but there's nothing that tells me from yards to inches, okay? Now, 1 foot is equivalent to 12 inches. All right, so now I have inches that are left on top, and I'm at the end. That means I'm done because I have made it from yards to inches. Now I'll just do the calculations. Yards cancels, feet cancel, and I'm left with everything on bottom is all ones, so everything on top, 120 times 3 times 12. I'm going to grab my calculator here. 120 times 3 times 12. It's a big number, 4,320. And that is inches. Did you know that's how long a football field is? Because it's just over 1, right? We divide. 4,320 inches in a football field. Yikes. Now, in the past, what I've seen students do, they just start multiplying numbers or just start dividing, and we don't always know when to do which one. So this is why we set it up this way, because if it's on the bottom, we divide by it. If it's on the top, we multiply. All right, we are going to practice a couple more here. I know this video is a little bit longer, but it's a lot of really good information, and you maybe didn't quite get enough last year. All right, On Tuesday morning, the school cafeteria served 16 gallons of orange juice for breakfast. How many cups are in 16 gallons? All right, so my starting amount is gallons, and I'm going to keep going until I get cups, okay? So I'm going to start with 16 gallons and put it over 1. Now, my formula chart tells me that 1 gallon is equal to 4 quarts. All right, and then if I look at that formula chart again, it tells me that 1 quart is equivalent to 2 pints. Okay, and then I keep going, and I know that 1 pint is 2 cups. 2 cups are in a pint, 2 pints are in a quart, 4 quarts are in a gallon. I have 16 gallons. Now, it says how many cups, right? When I get to cups right here, that means I'm done. I stop. So now I just start going through and making sure my units are correct, and then I cancel out what I need. So gallons on top, gallons on bottom, cancel. Quarts on top, quarts on bottom, they cancel. Pints on top, pints on bottom, they cancel. I'm left with cups. Now I just multiply straight across. Well, the bottom here is 1 times 1 times 1 times 1. The top, I'm going to have 16 times 4 times 2 times 2. So 16 times 4 is 64, times 2 is 128, times 2 is 256. And my unit will be cups. So my answer, since it's just divided by 1, it's 256 cups. Okay? Why a farmer has a bale of hay with a mass of 36 kilograms. How many milligrams? Oh, it's going to be such a big number. All right, so we start with 36 kilograms and put it over 1. Now, my formula chart tells me that 1 kilogram is 1,000 grams. And then it also tells me that 1 gram is 1,000 milligrams. Okay, look, I'm looking for milligrams, so I'm done. I stop there, okay? So I cancel the units. Have kilograms on top, kilograms on bottom. Grams on top, grams on bottom. I'm at milligrams, so I'm done here. But I'm going to be multiplying 36 times 1,000 times 1,000. I am going to get a huge number over here. 36 million milligrams. Holy moly, that's a lot of grams, right? A lot of milligrams here. But that's when you use this dimensional analysis when you have more than one step, because one basic ratio, this one here, is a basic ratio table. We have tons and pounds. Okay, the tree is 1.25 tons. And we want to know how many pounds it is? Well, we know that 1 ton is 2,000 pounds. That's a basic ratio table. We multiply by 1.25 here. Okay, that's a basic ratio table because we have the conversion on our formula from tons to pounds, or from pounds to tons. But when it's more than one step, you would have to do a lot of ratio tables or use this strategy. All right? Thanks, Rams.